All right, hello everyone, welcome back to the stream. I am Junchan, and today we are working on our prototype. If you followed a little bit of this series before, you know that we were working on a library for to implement the chronofold data structure, which is a collaborative text editing data structure. And we did the first version of it, and I wanted to jump into a prototype to get it basically, test it out and not get too lost in the weeds of trying to optimize things without having the perspective of, let's say, the user of the library. And also I'm interested in, seeing whether we can make something like a Twitch extension out of that collaborative text editing, so that I can have this log available for people to see as I edit it, and then maybe also play with versions where actually we allow questions to come in, or and maybe even further down the road, like code to be written in a somewhat collective way. So that's pretty ambitious, right? But the type of things that I'm interested in exploring. So oh yeah, I should probably give you my usual disclaimer if you're new here, is that the reason why I stream is to work and learn in the open, and I really hope that it's useful. But obviously things haven't picked up yet, but that's not a worry. I'm still getting a lot out of doing this practice. And yeah, also be warned, I like to follow tangents, since this is not, I do say work here, but this is not the paid for work. I don't have a boss to answer to, so I feel free, and I encourage myself to follow tangents, especially if I'm curious about something, then I want to learn about it. So that might break the flow. If you don't like that, then that might be a little bit troubling. So you are forewarned. But usually, I come back to where we were at, and so that's good, right? And so it also means that I should be able to produce edited versions of streams that actually really focus on one topic. And if you're interested in that, that's actually the focus of some of my streaming tools, stream on the Saturdays. And on Tuesdays and Thursday, we stream some Haskell work, which has been more of a how to get sophisticated Haskell libraries to work on Windows so far. But we're also spending some time trying to learn Accelerate, which is the library we're looking at currently. And so here we go. We're jumping onto our prototype list, and so what were we doing? We made a bit of progress last time. I opened up the way to receive events and pass them to the library we're using for like our, what is this called? Our UI, our UI library, I guess. It's a bit of a particular corner in the design space, this library. It actually doesn't use the VDOM, and by constraining its components, it's still components based, and there's still quite a lot of possibilities, including hooking up to events and whatnot. But it's the way that it constrains components mean that it can actually mutate, do the DOM mutations without needing a virtual DOM to keep track of what has changed in the component tree. So that's pretty neat, and I wanted to try it. And so the difficulty that we've encountered with it is that I still can't wrap my head around how to do the sending of events over the network. And that's because I need the events that I send over the network to depend on the current state. And even though there are examples on how to send something that doesn't require state, or do something effectful that doesn't require state, or do something that uses state but is not effectful, I haven't yet figured out how to join those things. So it means that we've been a little bit stuck. And so if I mean, I hope we can get to make it work, right? I have some ideas on how we get there, but so far we've been stuck. So, you know, that happens, and I'm not gonna be, how would you say, defeated by that. Not at all. This is a perfect occasion to learn, because it means that when I get this, and that's really a specificity of the type of programming that we're doing. And so I'll go back to the log just for a second, because, you know, I did a little section here on why we use PureScript. And PureScript, like other strongly typed pure functional, I should probably write PureScript is a strongly typed, purely functional programming language. Because I say that all the time, and I haven't yet written it. And like Haskell, except that it's strict, whereas Haskell is lazy. But it has things that are really useful to eliminate whole classes of bugs. It really is nice because the compiler helps me check my code before it runs, so I'm really in dialogue with my compiler to find out whether I'm doing something correct or not. And then the types help me think about my code better, and the patterns are really reusable. And that's why I wanted to go back to this little bullet point list here, because I know, because it happened over and over and over again as I learn more things about PureScript, that once I understand this pattern, then I'll see it everywhere, and I'll be able to reuse what I've learned everywhere. And so this kind of learning is super rewarding, because once the patterns kind of get into your thoughts, then you upskill. And it's not about knowing so much knowing a technology, it's more about knowing this more mathematical patterns, and then having familiarity with them really advances your capacity, or advances my capacity as a programmer to do better. And that it has proven before I was even programming in this type, but I was more reading and learning about patterns. It was already affecting my JavaScript, because that's what I wrote more of. And so it started to shape my thinking, and it's continuing to do so even now that I spend more time, or most of my time, writing purely functional programming languages. So, you know, buy it. This is my sales pitch. It really works, and I'm happy to discuss that more. So send comments or get in touch. All right, so let's get to what doesn't work. It's specifically this line here. In the simple case, we just take a log. We return an event of a function that takes a log and returns a log. So, and that function is basically the function that updates your state. And that's a hallmark of, you know, basically UI programming for the past, I don't know, 5 years now or something, where it's this unidirectional pattern. It's, you try to define as much as possible all of your user actions or your backend actions in terms of a change of state, and then everything derives from that, including what gets, you know, displayed on screen, and then what then gets offered to your user or to your backend as next steps to be able to follow in order to change the state again, and so on. So this pattern is present everywhere. It's present, you know, in React in particular, right? But it's here in this ability to return a function from log to log, but it's inside an event, and so that gives this extra capability, which is in this example that I picked up, where we can, in fact, do this little interesting thing where we create an event, and instead of doing pure uses then the applicative instance of event, and that just returns a kind of a wrapped function event without anything else. So it's basically, it makes out of the pure function, it makes an event that only applies a pure transformation. Whereas if I do something like interval 1000 and this, which is called void right in its non symbolic version, then then you see I remove the pure, and basically what sort of happens is that I create an event here, and then I kind of discard the result of the event, and instead I put my stateful function in it. And so here it's a bit like I construct the event, and then with this I sort of discard what's in it, which in the case of interval is actually unit or not instance. So I discard the instant that interval gives me, and I put in its place a function. So that's a type of thinking that you get used when you do purely functional programming, because functions are first class citizens in functional programming, and you get used to having functions as values that you pass around the way that you'd pass around, a Boolean or an integer. And so that pattern works. And so if I do this, then my state modification function will get run every second. This is an integer of millisecond, and interval repeats the event regularly. So that's all great, but my problem is that I need to send some ops, and I can get the ops from my component, but oh, hold on. Have we solved the problem here? Oh, right, we were exploring a different way to do things, and I don't know whether we were successful or not, actually, with that. Let me see. Were we able to compile this? Yeah, no, we had a problem. So that's one of the pathway that we were following. I think I noted it as using context to pass state down. And I kind of marked it, but I think we're trying again. Trying to get, last time we tried to get some inspiration from one of the existing examples, the tree example here. And so we'll do a little bit of that, and because that is a way to solve the issue. It would be a little bit unsatisfying, because I'd like to know how to solve this problem of sending an event. Where am I? Here. Or like this pattern of how you basically, it's basically applicative style programming that I'm trying to level up on here. And if we do this type of the context passing thing, then we're learning a bit more about SDOM, but we're not learning about applicative style programming. So even if I succeed with this method, then I want to go back to try and make it work with the other method. And yeah, my plan to make it to and get us unstuck with the fact that I still can't figure out how this works really, is to trace things from inside the library and go and try to figure out exactly. And I think where we'll focus mainly is the attach. Am I in the right? Oh, I'm in examples here, so no, I'm not. Right here, I think it's kind of where this happens, is when this push new model is basically applying our log-to-log function to the old model, and we already added some debug statements here. But I think I wanted to understand a little bit better how the event gets shipped, because basically in the case where we do, for instance, this interval thing, which works properly, then there is a step where the interval event gets registered as an event, and I want to see exactly how that happens. This way I'll be able to trace things a little bit better, and I think that will allow me to then finally figure out what this applicative pattern should be. And I'm pretty sure it's fairly simple, in fact. That it's going to be like, oh yeah, you use that combinator and it just works. But I've suffered trying to find out what is the pattern for a couple of streams. So I guess that once I'll figure it out, I won't forget it anymore. it will be engraved in my brain. But before we get there, let's see where we get stuck in this approach that uses the context passing. So we have a type error here. Yes, yes, yes. Is that whole thing about the fact that yes, right, right. That what I realized is that even though I thought that we'd have all we need in the tree example, because the first example that I was thinking about looking at was the array example, because that's sort of what in the docs is said to be using this context passing. That's the example. Basically says by passing the context, you can pass the index of the current subcomponent. So it's a way to pass something down to children components. And so in the case of an array, it would be the index of the component in the array structure, right? So if you had a list of an array of to-dos, and that you had one to-do component and then a to-do list parent, then you'd want to map your array of to-dos to your component and to the to-do component, and each instance of the to-do component will have a different index, right, or different unique ID. In React, it would be a key. And actually the key is needed to do the VDOM computation. But in our case, we don't need that, but we still, it's nice for a component to know what is its identity, right? I guess we share that as humans with components. And so I thought, okay, great, arrays, that's a great way we should look at the array code, but unfortunately the array code is super low level. Basically, it uses, and maybe at some point we'll be able to parse it and to look at it again. And maybe it is time to do that, but I think actually I will backtrack and not do that because it's really too unruly. There's too much event code in there and too much of the specificity of how the SDOM deals with sort of attaching, detaching components. And I think we'll spend too much time on something that we'd better uncover by doing the tracing and the applicative style programming. So my first instinct was, hey, let's go look at array. And then looking at the code of array, I was like, okay, I'm not going to get conceptual clarity by looking at the code of array. And so I thought, okay, let's go to trees then, because there's this example, and that's awesome. Except that what I missed is that was kind of not the cliffhanger, the kind of the disappointing ending of the last episode was, oh, actually, you know what? This uses the array code for the indexing. So basically, we're still in the dark because that's not really, I don't exactly know how we can actually pass that. And the idea, what we wanted to do here is pass the log state from the parent component down to the children component, because then that would allow us to do this approach where we're actually able to pass the log directly at the event handler level, as opposed to dealing with it at the interpreter level. And so we could build our operation at the component level and then just send it. And then we wouldn't need to have our sending to depend on that pure function. So we'd be fine. But apparently we'll have to backtrack. So what I'll do is that I will keep this and I'll comment it as sort of our tree context pathway, and explain that it needs to understand the low-level array component. So we'll get back to that. But for now, we will also I think we'll also kind of freeze that guy as part of the same attempt, and then we'll start reverting to our code. And so I'll put this downstairs so that it doesn't pollute our coding for now. And then we'll revert back to not using context, so that's correct. And then to do so our handler, we won't use the first argument of the lambda for the handler is the context. So we're not using this, but we're using the E, and therefore we don't have a log available to us. So what we're returning is not an array of op, but a function from log to array of op. It's partially applied build prime. And so that's actually right. It actually sort of works, except that now. Oh, that's interesting. Actually, it means that we could apply log to log ops, and that would actually type check. That's kind of funny. That doesn't solve our problem. We still need to send things, but at least this compiles. The fact that it compiles means that I can actually also reload the UI that we have lost for a while and inspect things. Okay, and yes, that means that I forgot to do a couple of things, a couple of incantations for the type of the Hyperswarm web module I'm using. And just running this should get us where we need. And I reload, and yeah, we're fine. Okay, so we're back to a point where actually I'm surprised that we are not running the interval regularly here. So I'll save again, make sure that it's compiled. Is it not working anymore? And what's the deal here? Oh yeah, we're using spy, but that's fine. Oh, right. Yeah, I need to hit the action once. Yeah, and then it runs every second. Okay. All right, so let's try and go back into what we're doing here. It is not easy, and I need to reconceptualize it before I dig into it. So we are using the pattern where we have an event of something which we don't care about, but let's say that it's unit, and then we apply it with this void right combinator, and this void right combinator has type fa to b and to fb. So it takes an fa, which is our event unit, and then a b, which is our log-to-log function. And out of that, it outputs an event of log-to-log. But what we want is an event that depends on logs. So how do we get this log smuggled somehow, or this event somehow smuggled into the future event log-to-log, so that we have access to log when we build our operation? And so at some point I thought maybe we could use because it seemed, I think this is applicative style that I'm bumping on, because and I tried to do this with monadic style, didn't I? I think I tried this in the learn repo. Not only that, but I think there was another combinator that was, I think it was the flap combinator that was also a candidate for things. Where is this? Yeah, I've already done a lot of trying to understand. Also, yeah, that's I tried to do it like, what if it was a monad? And I think maybe it'll be useful to get back to this, but first let me try and find the flap. So flap, I think, is with functor, then not apply or applicative. And maybe it's just a left. Check this out. Then if I have a function from A to B to C, like let's say ops to log to log. So that's kind of what we'd like. Ops to log to log. And so we have an event of ops, and I suppose we can make that. And then an event of, oh, we would have to say that it's of log to log. Yeah, no, I think that that's what I was trying to do. I was trying to somehow make the type match in a way that would make it so that C is log to log. But I think that's a bit confusing because in the end, I think it turns out that, well, that we have different logs there, and it just doesn't seem to be right. So that's let's say a possible path, and the other was, I think, in functor flap, right? Which looks a lot like void right. So I'm going to, well, I was here. I think it's clearer because I just did this. Yeah, flap is this. Which feels like it should be useful. And then we have, well, then we have lift2 that we were just looking at. That's A to B to C, FA, FB, FC. Which you can say lifts a function of 2 arguments into the applicative. And then we have maybe just, how is it? Oh yeah, TIE Fighter, as it's sometimes called, which is apply and is almost like flap, right? Except that our A is not in an event. And if we have an applicative, then it's trivial to make an F of A out of an A. So you can see how you can, for an applicative, it's easy to implement flap in terms of apply. So there's these combinators, and I don't know whether they're useful or not. And I'm not sure also what I mean by putting this event in here and whether that even means anything. So if we look at tracing where this event goes, when it is an event log to log, and what I gathered is that, and we'll close a few things here, and it's not in that main either. Or the package, or the Spago, it is in sdom. So what I gathered is that the event will come up here, and it will be subscribed to the push new model, meaning that that will be done once at attach when it's attached, but this subscription will mean that any event emitted will then have the push new model function be applied to it. And if you see here, and that's the symmetric with what we have in the type of the map channel, no, the with async here, and that's done through map right, is that we get an event log, and then we map right on it, and that gives us what with async expects, which is an event of either channel I2O, and I2O is log to log, and channel stays polymorphic with this trick of the fact that, well, we don't know what left is. We just give you the right, so it means that left is unconstrained, and that works for having the void type that is required by attach, but which is a neat trick. And I hope I remember this one, yeah, and that seems to imply some algebraic structure here that I can't quite understand, but it looks beautiful and it pleases me. Except I can't program with it yet, but you know, that's a detail for now. A detail that gets me stuck for three streams in a row. But hey, you know, fortitude, perseverance, enthusiastic perseverance. Okay. So we can see how this event of either void I2O or model to model or log to log gets passed inside this push new model function that gets executed for each event that comes through. And that's this push new model is going to unwrap the F here that's in the E by doing either absurd identity E and then get the F and then apply the F to the old model, which it got. How does it get this, by the way? Oh, the old model is in a ref. Right. So here we kind of, our pure code is touching the imperative shell, and we're doing mutation here. And so we have the old model. To get the old model, we just grab it from its mutable reference, and then we apply F to it, and then that gives us the new model, and so we can just write it back to the mutable reference. And then importantly, and I haven't paid so much attention to that, push it and push it with. So then we push it as an event. So we push it as an event. So there's another event going on here. Oh, right. We push it. Oh, of course. We push it as an event, which will basically funnel it somehow. I don't know exactly how. We'll figure this out. This is what I want to investigate. It will funnel it back into this input log right here. And so that is the final push that we see here. Here is what after we've done the backend, the changing the mutable reference, is what will make that model available then to our component tree after the mutation. So that's all good, but then let's try and dig a little bit into the details of this. So there's a couple of details here that I want to figure out. First is when we do this little trick here of, attaching, like creating this effectful event here and then attaching this pure function to it, it seems like there's kind of two payloads that we're putting inside our events, right? There's the side effect timer that's going to run every second, and there's the state function, right? And so the state function, we saw the path for it. It gets, unbundled from its either and then applied to state. That's all good. But what about the timer, so to speak, payload, right? This interval blah. Where does it get executed? And I was thinking that probably it gets executed. No, you know what? I don't even know. Because here the subscription is only for that push new model, right? So there's this smuggling of this interval thing that occurs, and that I don't understand exactly what is the mechanism by which the eventness of the because the log to logness function, the log to logness of the event is dealt with here by applying F to the old model. But what about the eventness of it? It seems like the eventness of it would be dealt by subscribe. So it could be that when we subscribe, we actually do the effectful thing, and then we pass the log to log. So maybe the key to understanding this is in fact in the subscribe implementation. And so let's look at the documentation first. Subscribe to an event by providing a callback. So callback is push new model, right? push new model. And our callback is effectful, but I don't see here anywhere where we to me it seems that at this moment, at the moment of either void model to models, meaning at the moment where push new model is called, or this callback for subscribe is called, I don't see that push new model knows about the timer. So let's take a look at the source to see whether this is right or what. So K is the callback, E is the event we get, and K is post-composed with void. I think that means ignore the return value, but I'm not even sure. That must be prelude void, I think. Oopsie. Right. So that it ignores the, so I think our K is an A to effect R. So it means that whatever we call our K with, and it means sometime at some point an A needs to be given to it. And I think that's what the role of E is, that the E has the machinery to pass A to a K. But whatever the A passed to the K, then the K might return something like an A, another A, and then with void we ignore it. And so that gives us the type of effect unit. And yeah, that's fine. And so to check, so now it means that and that's where there's like, like it's inception a bit, right? Like, because our K is a function that expects an A, but it's not subscribe that gives it, it's actually the event itself that contains the machinery to get the K. So we can see this here. It takes the K, it creates a ref with subscribers in it, and so probably that's kind of where we want to attach. We want to find that ref and look at it and look at its subscribers, and maybe trace through them, and then it returns so that the inception game continues here, because that's not even when K gets called yet. This is just where K gets actually attached to an array of subscribers. So K is now officially a subscriber, but it still hasn't run yet. It's going to run when push is called, and then an A is finally given, and then finally the subscribers are picked up out of that ref, and each of the subscriber gets past the A, therefore the KA here. So it is what it is, right? That's what makes this library tick. And this is a pattern that I've seen before. And when you do events and callbacks, it's always a little bit head spinning, which is all fine as long as we can track it. So I want to make sure that we keep track of our push here, because there's a push that's returned by attach. Because basically I want to know who pushes. Because our K is push new model, right? So push new model is going to be inside the arrays of subscribers. want then to know, okay, but who then pushes to it? And so I think, and I think that's different from this. I think that there's another event in here that pushes to the components. But what we need to know is what pushes to the events stream. And I think this is what tells us what pushes to the event stream, because that's where events are created, and that's in the SDOM type and machinery itself. So I think it's each element. So yeah, it's related to the type of SDOM, right? We return an event of that either channel IO, which has exactly the right type. And so who pushes to this? Let's take a look. So I think probably the first element, like text, for instance, that will give us a sense of how an actual SDOM component is built, and I think this will include all of its event machinery in a bit like we've seen at the edge, or at the level of events themselves, how these things are kind of delegated. Like basically, I think some of the event stuff, and we can already see it because there's subscription, there's pushing in here. Is there pushing in here? And there's no pushing in here, but it could be because events are empty. So I don't know what that means yet. So let's think about this. This renders a text node based on some part of the input model. So in theory, I don't see why a text element wouldn't have events and subscription. And so if we look at this, SDOM takes some stuff. No, sorry, yeah, we have this function, which is the state function for texts. Okay, so if we look at an example, we do use text in our component, and it's a very simple version compared to it. Like a div has all of this class stuff and the handler stuff, whereas text only has the state change for the model. So it doesn't have any. I don't think we have capability to attach an event handler to text, like we do with div, like for clicks or key strikes. We can only get state and something else, the context, I think, and then do something with that, like displaying it, right? So text is a little bit of a special case, but I guess it's a simpler case, which maybe we should take a look at just to also eliminate the noise of what other components will do, but other components will also deal with the other type of events. So let's take a look at it. So this creates text node, which is, I think, yeah, that's a low-level DOM mutation, and appends the child, and then it subscribes to E, which is part of the SDOM component, and it subscribes this old new. So that's exactly what gets called when by where we have at the bottom here. This push pushes into the SDOM component that we have been passed. In fact, the V here, that is our root component that we attach at the top of our application. That event is this event, and that push pushes into that event, and that's the one that expects to receive old model and new model, and that we see in the text element. That's what the E here is, and that's why we expect an old new when we subscribe to that event. And the component will just apply its F in order to the old, in order to get the new value, and also dealing with context if it needs to, and yeah, only mutate if so you will do a little diff, a little local diff. Okay, And then it won't emit any additional events. And text underscore is even simpler. It's static text. There's no use of that e inside the body of the function. So I'm following, and up to now I'm happy. Now we add the concept of attributes, because we're going to get into more of like the and handler, because we're going to get into the more containery DOM elements. Like element is the base for it, and the element has now a array of attributes, array of handlers, and an array of children components. So that's the type of div, for instance. And we have the array of attributes, array of handler, and array of children components. And so it could be, though, that some of the stuff that interests us is right here in the handler, but let's see how it's called from inside the element component. So we'll be interested in handlers. Events now are called updates, and that's probably because updates are the state updates, whereas handlers are going to be dealing with other type of events, right? So updates is what was called E in text, and I think that this would then be passed to this update function, and this update function is what? attr context E. Oh, so we do get past an E, but that's an element here in this function. Okay, so oh, okay, I see. So attr is also doing some eventy things, so we need to take a quick look at that. attr is something that takes a context and an element and return an init and an update, which is this old and new thing. Okay, and init is the initial model. And that's because attributes are dynamic. Yeah, attributes can also change based on context and state. So that's all good. But let's see the equivalent. Where is the equivalent of doing this old value, new value, and then setting the text content to the new value after diffing? Let's see whether we can spot where this happens here. And we bid the attribute and then subscribe the updates that we receive from the change updates to update. And so I suppose that this will deal with state with attribute changes, meaning that in fact that when an attribute receives attr. Right. Okay, it's in the attribute code. Yeah, attr. Got it. Okay, yeah, so indeed we find the expected update code that's been sort of factored away because that's reused for all the attributes, but it does the same little diff and then sets the attribute. So all covered, and it's all good. Now, what else happens? We have a set handler, so that's probably where some of the smarts that we're interested in occurs. First of all, when is set handler called? Well, it's called here on traverse, and so set handler is traversed with the handler. So we have an array of handlers, and so in our case it's just one. It's this key up. So this key up gets passed to set handler. So that's the shape of our key up, and let's refresh our memory with the type of handler. The type of handler. Type of handler is a function from a context and an element to an effect. So in our case, it's a function. So key up actually is something that we've built in the model of other event handlers, and it uses the handler constructor. So for this, we need to go again into handler, into the... Oh no, because handler, yeah, right, handler constructor this time is here. It's not in events. So handler just takes an event name, which I think is a DOM event name, and then creates an event for that. So we see that we have new events created, and then passes the f function to... Oh. First passes the context, then passes this to push. Which I think by then will be partially applied with the context. Right, because the context is static. Of course, of course. So actually, that means that what I said earlier about this other pathway is moot. We don't have another pathway because we can't pass. No. Context is static, so we can't pass the log in there. So it doesn't prevent us to try to understand the low-level array component, but what we understand is that it's static. It's on DOM element creation. It's assigned, like, you know, the identity of a component in an array, or the index of a component in an array, and then it doesn't get changed afterwards, and that's part of the SDOM constraints, but it's perfectly fine. It means it's good. Actually, I like that. And that's a strange thing for if I was a 5 year ago me, I would be frustrated by this. I would think, why isn't there multiple ways to do the same thing? And now I've started to see that it's really powerful when the library you use are so well structured that they prevent you to do something that is hacky, and that instead you can't. It's this idea that's really cool and taught by a lot of the functional programmers out there, which is making making impossible states not representable, or something like that. It's this idea that there's a certain way to structure your code so that you prevent errors by making sure that, for instance, in particular for this motto, that you create data types that simply can't be can't contain something that would generate an error. You make sure that they only contain something that actually would work, and then you catch errors before constructing them. And then it means that after that, in your whole application, you have guarantees about the data type being correct. And so here we have an echo of that, because the fact that the context is static means that we can't do my trick of passing the log through this. And so it means that, no, we have to use the proper way to do it. And the fact that this is the case actually kind of gives me a fuzzy warm feeling that this is well designed. All right, so that's good. That limits also, that means that we can remove something from our log. We could say that yeah, well, using the context to pass state down, it's like, no, context is static. Done. So that's properly checked. We can check it even with a big X this time. It doesn't mean anything, but it's just fun to do that. All right, let's go back to handlers. And I will drink a little bit before doing that. So if we backtrack for a second, we had set handler called with one of our handlers, and that was the handler key up for us in our example. And we built that key up handler with the handler constructor. And simply by partially applying it with a name, key up, which means that we're just waiting for that function of context to event to E. And that E is in fact this, I think this, yeah, it's this either that we've seen already quite a bit. And so that's why we have it left here. And so indeed, key up, expect context and event. And so let's clarify something here, because event.event is what the code in the library for things like keyboard events or like change event or click events from the DOM, they're listed as event.event, and that comes from this web.event.event library. And I don't know, it feels like it's used exactly like an FRP event, but I think it's not at all an FRP event. And when we looked at it before, I think I clearly confirmed that it's not an FRP event at all. And so we want to take a look at it and see whether maybe if we squint at it the right way, it actually is a FRP event, or whether it's just using a completely different API. And so let's see, I think it's internal type, isn't it? Yeah. The event type, which is what we're using, is a foreign type. And that foreign type hold on. Right. It doesn't have any definition. It's just a basic holder. Like, I don't even know how to necessarily think about this. It's meant to be a foreign type, so something that's that we can't introspect really. That's just given to us by the outside world, and it sort of implies with no, no real interface to it. Really, it's kind of an opaque interface. It's just a blob that can be passed around, and then I guess that some function in the API can do something with, like these guys, right? Which use the event as and so all of the API can take an event and work with it. So that's fine. But how does it help us understand what's happening in handler in particular? Because handler uses this event.event. Right, of course. So oh, holy moly. So here this is where these two APIs meet, because here this create, that's the FRP event create. See? Whereas the event listener, that's from the web event API. Yep, event target. So that event is what we call here event.event. Whereas event is the FRP event. And so here we have, I think, what is really just a wrapper. It's a way to transform, it's an adapter. It transforms, it creates the machinery that we'll need to transform things into an FRP event. Then it creates this listener function from the function that's in the handler, in our case, this one, the left-right blah. Partially applies it with the context. So now we have a function from, at this point we have a function from log to log, so model to model, because we've applied it to the context, right? Check this out. Right, f being passed the, sorry, not log to log, event to this either blah. That's what we have. And then we push that, but actually we don't, push is not saturated, fully saturated here. It's not, it's still partially applied. It's still waiting for some event to get into it. I'm pretty sure, because f context is a function of event to e, and so push's type is what, by the way? Push's type is push's type comes from create, and it's a to effect unit. And so here we post compose. We don't pass f context to push. We say the result of f context, which means whatever comes out of having passed an event to it, which will occur later. Right now we haven't received that event, but we say by post composing push, we say, well, when that event is received, then you f context is going to have an e, so now we can push that e. And then this thing we pass, so like inception again, inversion of control, we pass to the event listener, which expects something of type event to effect whatever. And so indeed, we have that. Our f context means that we have an event to whatever. And so we get the event, and the whatever is in fact push, and push is going to take the a and return an effect unit, so we have our effect a. So I'm going to write this down here because I might go back and look at it. So f context is of type event e, and then push to f context is of type event to effect unit. And the e gets passed to push. And the event listener, what does it do? Well, it takes this callback such that whenever the event happens, I suppose, well, it's a little bit, there's another indirection here. I think it gives us a listener. So let's, oh, it's to do the unsubscription, I think. Yeah, to do the events, well, no, actually, it gives us a handle. We can do the unsubscription with it, but we then have to add an event listener to complete the subscription process in the web event API. It's actually simpler to do this with the FRP event, which is why, by the way, this FRP event is used. They've decided to use it for Halogen, and I think that that's a great endorsement. It means it's really good at doing exactly just what it needs to do, which is sort of provide a solid API for any event subscription, really. And the fact that this comes out of the behavior package is also pretty amazing, in fact. But let's not get lost into this. So I think, yeah, basically this web event library we need to have a little bit more ceremony to deal with things, which is probably just to kind of have the proper impedance match with the web API. Okay, so let's look at let's read the documentation here. So event listener creates an event listener from a normal purescript effect function. So this effect function becomes a web API event listener. And this function itself is effectful, as otherwise it would break referential transparency. Well, that's something that I wouldn't expect to read. The need for something to be effectful for it to not break referential transparency. Huh. But otherwise, event listener F would be different from event listener F. Huh. This is worth noting, as you can only remove the exact event listener value that was added from an event target. I see. So that has some homotopic consequences. Identity, so fun, but I mean, this has its importance, but we can discuss this later. Okay, and then if we have in hand an effect listener, then we can pass it to add event listener that we take the event type, the event listener, a boolean that indicates whether the listener should be added for the capture phase, which I guess is the web API thing, the event target, and then it's kind of finally we've registered the listener to a particular event. So it's a lot of ceremony to just get something to tie into the web API correctly, and then remove event listener is going to want the same thing. And then I suppose then other things will dispatch events, and then they will be listened, and they will call this callback, which in our case is something that pushes and therefore adapts the web API event into a FRP event. This makes me dizzy, but I love it too. All right. So here, we're not listening during the capture phase. Our target is whatever we got from the actual event. That's in the handler. The event name we wrap into this new type to get this event type, and that's the web API event name. So key up in our case is this event type. What did I do? I deleted it. Yeah, key up, and specifically this string here is what gets wrapped into an event type to create this JavaScript type. Listener. So listener, there's another indirection here, which is that we get it. We're in the effect monad here. In here, in this do block, we're in the effect monad. And so when we do this bind, we get the actual event listener, not the effect event listener, right? We had an effect event listener here, and we bind it, so now we have a listener that we can use to actually properly call add event listener here with the unwrapped event listener. And so what this means is that when a JavaScript event will be dispatched, in the case of the browser, the actual browser will call this. The browser will launch the key up event because it's in charge of managing the keyboard I/O. So when that fires, because we've registered key up, listener will be called, and then the inception, right? We wake up, and the alarm bell rings inside the dream. We call. We have an event here, so we can call the callback that we built with event listener, and that's this push. But this push itself first passes the event by fcontext. So fcontext finally gets. It had its context, but now it finally gets its event. So great. And then it outputs an E, and now our push gets an E and is able to do effect unit. Because, of course, I should have mentioned here that the type of push is, let's say E, it's really A, but to effect unit. That's its type. We can look at it again here. A to effect unit here, right? So then So then that push is called, and we're still in the van here. We've waken up from the hotel, but we're still in the van in Inception. And so now we push, and then that actually then gets where? Well, that gets into event, which is passed as the result of the sdom, not the sdom component, the handler type. Okay, so we're getting there. The result of the handler type is an event. And so that on creation, it contains this type of events that you can, and you see that it actually doesn't pass up the push. So all of the push machinery and the push wiring is delegated to handler. There's no escape hatch here, because once the event then is passed on to the caller, then you can't push to it anymore. But in other contexts, right, like that we've seen below, for instance, with attach, in other contexts, the push action is actually passed, but that's for a different action. That's for the push model action. Here, we don't pass it, so all effects need to be handled by the handler. So when will so what happens? How do we continue our chain of wake ups here when the key up is pressed? So we said calls this, which calls the listener, which calls the f context, which calls the push, and the push is going to push that event. Push to that event is the better way to think about it. I think maybe what I said is not completely true. I think maybe you still have an escape hatch. Maybe it's still possible to rip open the event and somehow push into it. Maybe. Not even sure about that. But we return the event, but that's, I think the returning the event here is more, I'm curious about why we even return the event here. I need to try and understand that, because we return it on creation, at creation. The actual what we do at creation is we wire things so that event will stream, and then we return a thing on creation. It's not, yeah, that return here is not going to be called at each event. It's only going to be called once when we deal with the handler. So let's see how this event is handled after that, and then I'll continue with my bubbling up of things. So when we set the handler, and then when we set the handler with the handlers, then now here our handlers have that type, right? Have the events E in it and the unsubscribe, but we don't really care so much about this right now. And then we call set handler on it, and set handler is going to open up the handler. Is going to pass it the context and the event. Oh no, and the node. Handler needs handler. It's here, right? Handler needs context and an element, and then it will return. It will return the what we built here with handler. So when we pass it context and the element, then we consider set handler called, and so it means that the result, what we get out of set handler, is this data structure. Events is this data structure here, because we do a bind, and so we get this record. And so it means that when we do underscore dot event evts here, we are doing the using a field accessor syntax to get inside here. So that's what I wanted to see earlier, right? Is we are using these events, which, by the way, by now are not only, so now they've acquired this type of either channel IO. And so handler normally is context and an E, and context and an E, and things were polymorphic here, but now we say, no, actually handler has type either channel IO, which is, I think, in the documentation, when handlers are talked about, yeah, then the result type of each handler is either channel IO. That is, an event can either update the state of the current component by doing right in the either and then doing the I2O, or left to pass a message to a parent component. And so that's indeed what happens also here, which is that we see there's something about the alternative of container events and children events that are collected in this way. So that's the events of the element that is under consideration. But since we also have an array of children available, then actually there's some traversing happening with the children, such that we get out of it the children events. And apparently that's done just with an sdom. An sdom is just the unwrapping of sdom, and doing so give us the same shape as the handler gave us, which is which is this effect of events and unsubscribe, which is really what is packed inside this sdom type. Right, an sdom is right here, and yeah, of course it gives us the same thing. So given an sdom, it will return all of the things from it, and we're only interested in the what in the element component, what we're interested is only the return value out of the effect monad. So let's see, what is the traverse? Right. Oh yeah, because then we apply an sdom to all of the right things, such that we get the effect returned, and then we can we get out, I suppose, an an array of children events here, which is why we one-off map. F is foldable, that's the children events, and then A2GB is the field accessor, and so we get an array of events instead of an array of records which contains events and not subscribed. And same thing here, we unwrap on the other direction. Okay, so yeah, right. And then we do also have an array in events here because we had an array of handlers. So at this level, it's not that we have these arrays are not arrays of events that are waiting to be processed. They're not. They are arrays of the type of the events that are wired statically at the creation of the component tree. So, but there's several of them because we can have several handlers here, and then obviously each children can have several handlers, and then that whole traverse is going to just aggregate all of the handlers of all of the children and create flatten the array from that. And I suppose that the traverse is going to do that somehow. And then I'm curious about this alternative. It's not alternative, it's actually alt. And I need to document myself on this because that's something that I'm not familiar with. I think those types are related, but they're not the same. I think one depends on the other. So alt, an associative operation as a type constructor, similar to semigroup, except that it applies to types of kind star, like array or list, rather than concrete types like string. So a semigroup instance on string would say, okay, give me 2 strings and I give you a new strings, which is the concatenation of the strings. Whereas a alt, then if it's similar, we'll say like, well, if you give me a list of integers and another list of integers, then I give you another list of integers because I know how to basically append those lists. And so it needs to be associative and it needs to distribute. So that looks a lot like the type of mapend for the semigroup instance. So we're just mapending those arrays, and that's just the way that the pros do it. Instead of, I would probably do this, and I would use the semigroup instance of array. So what would wouldn't this compile? No, it doesn't. And the reason is that there is no type class instance found for O1. One-off map returns a GB. Oh, I see. It folds the structure into some plus. So we're in abstract land here. Oh, I didn't even notice that this uses what is this, void right apply or something? It's the apply that ignores, oh boy. Okay. Okay, so I need to understand one-off map because it's a little bit all over the place as well. I mean, it really is what wires the events. Okay, let's find one-off map. Foldable traversable. Takes an FA, which is foldable, and folds it into some plus. So we moved from, oh right, so that's the reason, is that we're not anymore into, we can't mapend because one-off map is just a plus. It's not a foldable, and meaning it's less like a list and more like a what? Don't know. What is this plus that we've just folded onto? Let's see if we can find it by type annotating. That's the plus. So it means that, and these are FRP events now, right? Yeah. Okay, so let's look back at FRP events and see the instances they have. their functor, their compactable, which I don't know what it is, their filterable, which I don't know what it is, their apply, which is a superclass of applicative, so that I recognize, but not very good at understanding what it is, and alt we're just seeing, and so so there is a specific, yeah, the alt instance is it means something. It's so when we do this, we need both the alt and the plus, and so the alt takes an event of f and an event of g, and makes sure that anything that's subscribed to the alt of those two is going to be subscribing to both. So it makes sure that f, if we subscribe or push to the alt or the composite, the alt of those two, we in fact subscribe to both. And then what we do with the result is that we ignore, there's some precedence happening. We ignore the result of the first, but we run it, but we return the result of the second. So meaning that in this case, we will run the, well, let's say we'll attach our K, our subscriber, to F. That's all good, but we'll ignore what will we ignore? I think maybe I need to, well, I probably need to open another. I want to have one off map visible. Control apply, and it's apply second. Right. Combine two effectful actions, keeping only the results of the second. Right. So, okay. So I think so again, this doesn't mean that we are like those aren't events. This is statically registering the subscribers. So we do the subscriber registration here for both sides. However, at registration time, we discard the result of the first registration, and so we discard the registration for the container element, and for some reason we return the registration of the children element. And notice that at this point, we actually even haven't registered anything yet. Basically, it's the moment where we call something of type element with some handlers and some children, then that's when this will percolate and get registered. In fact, let's look again at our attached type now, because in the end, it will percolate here, meaning this is our root. And so once all is finally alted and plussed and passed up the chain, then that's where we wake up and we spin our to stay with the inception metaphor, right? We spin our, how's this called, in French into P. Yeah, that thing, the thing that he keeps as a memento to turn, and then we don't know whether it's going to fall or not. To know whether we were awake or not. Here we are supposed to awake. We're supposed to be back at the top of the imperative world outside the pure world of mathematics, and we start executing things. And so we've gathered all of the events of our component tree into this type, such that now we can subscribe the composite of all of these alted and plus things to push new model. And so now any event that comes from any of these deeper levels will get, once it will fire, will get passed to push new model. So that's all good. And does this mean, so what it makes me think about is that, first of all, could we use the alt or plus instances? Well, I want to dig a bit more into understanding why do we convert this alt instance into a plus instance. That's one thing. And then I wonder, could we use these combinators, these alt combinators, instead of this here, to combine our events? That seems like that's likely that we could do that. So that's nice, because basically it means we've only used the functor events. I still don't understand why by using the functor instance we're actually able to even well, I guess because this has an event payload and this doesn't. Yeah, I'm still confused about how this actually works in practice, and we'll need to trace through this, but now at least I think I'm able to follow things, but I feel like maybe this will be what saves us, maybe, these combinators. I don't know, maybe not. Okay, go back to the library code, and okay, so let's try to understand why we are taking this event either channel IO, and why are we using one-off map, and why do we need that? Why do we need, why isn't this underscore event sufficient? Why do we do one-off? And then why do we alt them? So we do one-off because events is an array of things, and we don't want an array of events. We want an event of some combination of things. So one-off map moves us from this world of arrays into this world where we've meaningfully combined the events. We've explained what the semantic of array combination means. We've decided what an array of events mean when it's combined with another array of events. Well, that's what I just said. But this is, we've decided what combining an array of events into an n single event means. Not a single event, a plus event. Oh boy. Our container becomes some kind of plus. So what is plus? What is plus meant to be? It extends the alt type class with a value that should be the left and right identity for, oh, okay, I see. So it's like the monoid to semigroup. If alt is the semigroup, then plus is the monoid, because it has identity. So that allows us to deal with the text, for instance, that has the empty thing. Right? We saw that text return an empty. So if we have now empty as part of an array of things, then with plus, we know how to deal with it. Got it. So that's subtle, but that's what pros do with APIs. They understand what invariants are, and so it means that we know that we might have an empty in here. So doing one-off map makes sure that we know that we want to allow empties in our arrays of children, or and so therefore, I mean, actually, will we have empty coming in from from the handlers, because this is coming from the handlers. So why and when does a handler return empty? I don't think it does. I think there might be a way to this takes an out. Yeah, I think this could be map. No. Oh, because it's an array. Yeah. Right. Yeah, we still need to, well, we need to alt it. So we need something. I see. The only way to alt it is to have it plus. There's no such thing as a one-off map for oh, well, no, hold on. We're taking the foldable. Right, we need to... Oh, we need plus because in case we have the empty array, that's it. If this was a non-empty array, then we could have like some kind of whatever would be able to deal with alt. But I think that usually you don't have this in Prelude-like things. Non-empty arrays are not common currency. But I think theoretically, if we had non-empty array, then we'd know that we don't need the plus because we wouldn't have an empty array. Okay. Okay, I mean, I've convinced myself here of why these types are needed. That's all well and good. Now we are also so let's understand what the, well, right, so the plus instance of event is only going to be this identity thing, actually the empty member, right? And the empty member just ignores its input and just returns a unit. I think it means this returns a oh, and that explains what this is. It returns an unsubscriber. Is it an unsubscriber? No, because our subscribers are different here. So event, hold on 1 second. Providing a callback using the subscribe function. Event do this double. So yeah, no, it is the unsubscriber. So how come we also have other unsubscribers here? No, hold on. Create gives us an unsubscriber. Make event doesn't necessarily give us a subscriber. No, but it is in the type of, so I think that when we do pure unit, we're saying there's no unsubscription that occurs because we don't deal with that. So the return type of effect unit is that you get, in an effectful manner, you get an effect unit that you can use to unsubscribe, and that's this guy. And in the empty case, it's just empty, like it's just pure units, and there's nothing that happens in between. Sorry about that. Actually, it's a good time to take a break and also wrap up a little bit warmer. And yeah, I'll go on for about 20 minutes more, and I'll take a 2-minute break. All right, I'm back, and I realized that I didn't put the music overlay title in the My Be Right Back screen, so I will add it and switch back. Okay, done. So this stream actually turned out to be a fairly self-contained going into the bowels of purescript-sdom. So it's useful, I think, maybe. I mean, yeah, maybe. It's useful for me. I'm learning. I mean, after all, like looking at how, like, you know, like indeed, like what I call professionals, masters, that the people who are writing the programming language and the key innovative libraries, how they program, that has to be a source of inspiration, right? That has to be a way that you improve your craft. So it's definitely not time wasted in my book to go deep and understand this code, because I'm like discovering Alt and Plus, and I have some example that I can remember for later. So all of this is exactly like learning in the open. Okay, so now I understand a little bit better, because now this pure C1, C2, what it is this is about unsubscription. But now I'm like, okay, but does this mean that we don't? Oh, it means that we so this pure is the surrounding effect, yes? So both C1 and C2 are going to be effect units, right? Because events are effect of effect unit, right? Return effect of effect unit. So in here is an effect unit, here is an effect unit. And so what happens when you ignore the return type? Well, the return type is unit. So it's all good. So so this basically says, well, yeah, it's really arbitrary. But what it says is really run the insubscription for C1 and then run the subscription for C2 and return the unit from C2. Not the unit for which is obviously the same unit for C1, and in fact it's the same unit for any of the events all around. But the insubscription is still going to run because we're doing this applicative composition here, meaning the effect is going to run. And it's just that we ignore the return type, which is just unit, so it's all good. All right, so that's understood. And then when we do the alt here, we're doing that same thing. So now we have this way basically to have subscription that is being done thanks to this mathematical structure, these type classes. You know how to arbitrarily compose this tree of components into flattened arrays of those trees that are then composed together with these alts, such that you can pass a single subscription at the top and it will be in fact passed down to all of your component below. With, I believe, then maybe some subtleties around the fact that you have this profunctor structure with the I and the O. And so it should mean that when a parent wraps a children with a lens, then that somehow the F, the part of the subscription, the subscriber callback that does the state change, that gets properly lensed. And so I wonder where that lives. Maybe in the profunctor instance. Well, on the profunctor instance of sdom, so therefore here. Instances, profunctor. There we go, over events. So that, I think, gives us a tip that we're doing something to the events of the contained of the component that's below. If we consider that we have something like IO, and that in the parent component we have an IO, and so like and that's the smaller IO is picked inside the bigger I. So typically this might be a pair of A and I, for instance, and this might be a pair of B and O, and so, or a small o. So I is a pair of I, like maybe it makes more sense to like this. What do I do? I don't know. Right, something like this. Right, so it does make sense to have a spacer here. So then our F is second, that picks the second in the tuple, and our G is second, it picks the second in this tuple, the output tuple. And so if we have that, then wow, die map. Well, yeah, I suppose we have several structures that we need to go into. So let's try and understand this. So we create a bigger component here. And the bigger component takes the smaller one, which is here, and then does something to like passes it the context, but the F of the A. So it removes the first part of the tuple and passes only the I to the children. And it does like some because the pushed state contains old and new, it actually applies oh, I'm a little bit surprised here. I would have thought that would be G. Because we get out of the row sdom thing, we get this oh, right. No, I'm confusing the constructor with the position of the type variable. Even though sdom's type has I and O in third and fourth position, sdom's constructor has I in the first position, but an event of old I and new I in fourth position. So not a no, but an event of old I and new I. So that's what we construct here. We make sure that we get the old and new I from the inside component, but that we wrap them properly into no, hold on. We get the old and new from the top level component, and when we get that, we pass down the stripped down version to the bottom component, together with the event that's not the event. That's exactly that. Well, yeah, it's the event, but it's the event of old and new. Don't know how to call this. And then we use over events, and I don't know what over event really is. And so we do. So if it was me, I would think that with this we're done, but we're definitely not done because of some kind of event subscription business. Is what is the type of this whole thing? Effects of events and unsubscribe. Which feels like that's exactly what we want as the results of an sdom. We want an effect of events and unsubscribe. Except that we're not done. We have something more to do. We have to do something eventy to it. Is it because of the channel? Don't know. Well, it is the only place where we actually do the die map. So I guess just from a type perspective, we need to, at this point, despite having done our work, we still have an I. No, at this point, I think our I is properly typed, but it's just that our G is not properly typed. So could we get away with die mapping identity here? sdom and context A. We pass the A to the F. So at this point, it seems like we'd already have the right type for on the F side of things, wouldn't we? It's just that we need to get a type for the O, the output type of, and it's said in the doc somewhere that the perfunctory that this O is really used to get the perfunctor instance. So let's look at it. Is the type of the model when used as an output. Events raised by the component may change the model by providing a function of type I to O. And the model is split into input and output type arguments to allow the perfunctor instance of sdom to exist. Yeah, so if it's possible to change the output type, and by the way, how do we get that output type? And then does that even mean anything? I mean, where? Okay, another way to think about this is how does the data flow wiring of this occurs? Because it's not one-to-one mapped with the event flow, because the event flow is going to happen through these event wiring, subscription, and handlers, and then they might modify state. That's all good, but then there's a data flow aspect to this, and I guess I haven't seen. It's because we have only a flat example for now, but I guess maybe they would be more obvious if we did components that did transformation. And if they did transformation, then I suppose also like that the output type of f, no, the output type of f wouldn't be sufficient because f is applied to the input before it occurs. And the G is applied afterwards. So with this, we change the. And I think that we change the output type, but I think also what we're doing is like we're sorry about that. We intervene somewhere that's going to impact this bit here. The application of the push new model subscription. When we do this, we get the new model, and then somehow this wrapper or this die map and this other event combinator is going to change the output of the new model using G. And we pass over events, and it's passed to this monster. Let's see what the type. It's going to be too generic. The type is going to be too generic. We won't be able to understand anything from the type here. Oh no, nice. It's not so generic. Right, it's totally perfunctory. Oh, right. Okay, so those two maps go under the event and then the either, and then focus on that f, that state transformation pure function. So, and then applies the die map to it, which means that we get the f and g are able to transform that a into a the b into an a and the c into a d. And over event just goes into one more layer, and oh yeah, it's because we don't have a map for records, and so that's the map for records when we just want to apply this to events. And so all of that allows us to go deeper into this guy and go under and go into events with over events and go to inside event with the first map inside the either, and then change the input type and the output type of the die map. Okay. And that looks like map, right? Map would be of type A to B, FA to FB, and well, let's even say that it's yeah, no, that's good. And then we'd implemented something like F and A, and would say, well, we kind of need to, was an array, let's say, array B. Then we'd say something like, well, you deal with the empty case, and that's just the empty thing. And then you deal with some, oh, yeah, I'm supposed to stop now. So I'll just finish this. And so you have an array of A's, and then you take the head of the A, and you know, it's probably even better if I do it with lists, even in PureScript. It's simpler. Can we even pattern match on lists in PureScript? I think we can, yeah. So yeah, it's an A followed by A's. And then we'd we'll F on the A, and then we'll map F on the A's, right? But in the case of over events, we map our A, our F is F, our O is something that has events in it, so we need to go into the O events and then apply F to that, and then we rewrap it with events, and that's what we put inside our original O, leaving all of the other rows intact, and specifically the unsubscribe. So it's not exactly a map. It's I mean, it has a bit of the structure of a map, but it actually leaves the rest alone, so to speak. So if we say more like something like that, or whatever. Okay, what did I do? What are you unhappy with right now? A cycle? What? Did I... Maybe I accepted some import to be added while I was adding this? Yeah, probably did. Okay, and we compile again. I believe that this is just our spy things. Yeah, okay. All right, so I think we could say that this was part one of a in-depth tour of the purescript-sdom library with a specific focus on the event path. And there's something that I haven't quite completed, but that would be a nice way to pick up on the next episode, and I'm going to make to write that somewhere. And in fact, maybe this is now a new section. In-depth tour of the purescript-sdom library that we do in order to try and understand our problem. So that's a tangent, an educational tangent. We want to follow the event path even more in depth with regards to to elements and handlers. I was starting to track the web API key up event through quite a bit of things, right? There was through the web.event.event types with this adapter, through the handler adapter, giving a FRP event, and then we part of the way inside element we were looking at how set handler Right, set handler really registered the callback for a container element. Right, the callback being the context to event of the context event to event dot to e callback in a element. And then how events are aggregated via the plus and alt combinators. Container and children events are aggregated via the alt and plus instances. And then how then it flows into the top level subscription, and that's kind of where we were, how it flows through the top level subscription in attach. And so we've done all of these, but here I think we need more details. And this hopefully will answer our question. Then we can even trace it to, confirm our more right now, reading the code understanding and see if we, at least by positioning a few judicious spy statements, figure out exactly how this event gets unpacked and why we, what does that mean about how to create the event that we want to create for writing our operations. So yeah, I'm glad I repurposed this as a tour, as a tour tangent. That makes me feel a little bit better because it's better reframed than the fourth stream that I can't solve that problem about how to send events. Instead, it's now a tour of the purescript-sdom library, and I hope you can do the same for when you get stuck and not give up, and especially with this kind of programming languages, there is a high barrier sometimes to crack some of the underlying abstractions and sort of finally get them. So perseverance is required, and for that, you gotta cut yourself some slack. If like me, you don't visibly make progress on your prototype for 3 sessions. So that's it for me. I will see you tomorrow for some Haskell on the GPU, and yeah, thanks a lot for being here. Bye-bye.